Good morning, everyone. Today we'll be going through plotting line graphs under a certain domain. So let's first go through what a domain is. So a domain is basically boundaries from which the graph is going to be between. And usually it's set between the x-axis, but it can also be set between the y. So a typical domain set between the x-axis would look something like x is between 3 and say 7. And when we use these square brackets, it means it's including these points. So how the domain would look if it wasn't including 3 to 7 would be just curly brackets, 3 to 7, something like this. So a domain like this would actually look like, say this is x and y, 1, 2, 3, this is 3, 7. So the domain would be everything inside this area here. So everything that's larger than 3 and smaller than 7. Alright, let's rub this out. So let's try a question. For example, if the question said, plot this graph, y equals to, say, 2x, where x is between 0 and infinity. So first, let's graph the y equals 2x first without taking in context the domain. So y equals 2x. For those that know, the 2 is the gradient, which means that for one step that the x value moves up, the y value goes up twice as much. So first here. And if you're ever unsure, you can always plot in a graph. So for example, if we're unsure how to graph this, we could sub in the point x equals 1. So when x is 1, y equals 2x, y equals 2 times 1 is 2. So when x is 1, y is 2. So the point will be there. And we keep going like that. So if you can't tell, the graph would look something like this. Yep. So it's quite a simple graph. And now we put in the domain. We want the domain for x to be between 0 to infinity. So how we denote that is we get x equals 0, which is here, x is 0, and everything lower than that we get rid of. And how we show that it goes to infinity is we write the arrow here to show that it's an infinite graph. So there we have it. This is y equals 2x, and the domain is 0 to infinity. So let's get a harder graph now. Say the second question is something like 4x plus 2y equals to 6. With the domain being between, let's just say 3 and 9. Yeah, including both points. So how we do this is we first need to rearrange the equation so that y is the subject. So it becomes 2y equals 6 minus 4x, y equals 3 minus 2x. So what we know about the graphs is that this right here is the y-intercept, which means that the y-intercept is 3 in this case. So 1, 2, 3. Yep, right there. And we know the gradient is negative 2x, which means that for each time that x goes to the right one, the y actually decreases twice. So let's start plotting it. So every time x goes along 1 time, y goes along 2. So 1, 2, here, 1, 1, 2, here, 1, 1, 2, here. So now you're seeing the pattern of the graph, and we can just get a ruler here. And we'll draw the graph. So that's what the graph would look like. Something like that. And now we need to plot the domain. So the domain of it is between 3 and 9. So let's see. Let's find the 3 first. So 1, 2, 3. 3 is here. That. And now 9. 3, 4, 5, 6, 7, 8, 9. So here. So the domain has to be between 3 and 9. So I just could extend this graph a little bit. And we have to make sure that the graph is inside that. So everything out of it, we erase. Yep, something like that. So this would be the graph 4x plus 2y equals 6, with the x domain being 3 to 9, including. And I forgot to mention before, but how we signify that it's including is we put the solid dots here to signify that it's including 3 and 9. And if, say, the brackets was like this, x is between 3 and 9, the dots would be like this. It'd be an open dot to signify that they don't include 3 and 9. And as always, I've attached a worksheet below so you guys can practice. And thanks for watching.